So this is our fifth tutorial session on FEM of welding processes. Today would be going slightly, we'll digress from our topic. We'll be reviewing some plate theories, linear shell theory, and how they are implemented in Phoenix, especially with the formulation of linear shell theory. Then we have started. So it's like we'll revise our that we are doing, right? Fezula's work.
Yeah.
So it's like we have to understand all this. I mean, the elastic, it's just about all this mapping we have to understand. So what I'll do is today we'll actually go through the book just to understand these notations, since we need to just clear things up. Yeah, I think that's what we aim to today.
Okay.
So today we'll just clear our things,
Clear
all these things up. Yeah, I think because since in paper he has only talked about till here, right? He did not give the, he just uses all those automatic differentiation functions, and he has not given the complete expression of how this with both superscript and subscript, right, in the same article expression. So this we need to understand. So I mean, not understand, it's just like how do we map from E alpha beta to E beta alpha. So we just want to understand this today. Yeah. Right, so what we'll do is I'll just open that book relevant section. So let me first go through the contents of the book. So in the online copy that I have, they have not presented everything at one place. You will see, right, in this book. In this book, what happens is maybe some person who has, uploaded this book. What they have done is they edited this PDF such that the contents of this one, right? They have deleted the contents of the book. So there is no contents of the book. What they have done is, like you see in every chapter 1, there is one chapter 1 here, all the contents, and then in chapter 2, the local chapter 2 contents. So that's what anyone who has uploaded has done. So let's just go through this book from Google Books. I just found the first few pages. So that we can know what is the contents, right? So here it starts with tensor analysis, the coordinate transformation, contravariant transform, the tensors, covariant differentiation, Riemann-Christoffel tensor, then covariant differentiation, geometry of the middle surface. By now we have understood what is fundamental form, normal coordinate, second fundamental for invariants of curvature. We know now inverse of problem we have, and the equations of Gauss-Codazzi is just links. It's like compatibility equation. What we had for Aries, this one, right? Equation, Aries function, Aries equation. So similar to that, we have equations of Codazzi. They are also compatibility equations in what you call for geometry of surfaces. Then we have kinematics of surface. This we have already seen, stretching and bending part. Then statics of a cell, effective forces and moments. We don't need to do this. All that we need to do is, I hope, okay, he has not given more material, it seems. I will not go beyond. Okay, it's possible. Okay. So see that? So it's like, I'll just zoom in. So you have, so we were here, kinematics and statics of a cell. Then we'll just look at the relevant, just to understand that terms. That's our aim, not to go through the book. So stress strain relations, static geometric analogy, plates. Obviously, plates is not we are looking at. Membrane state also we are not looking at. Bending of circular cylinders, no, we are looking at spherical shells. Axis symmetrical bending of cells, this is the one we'll look at. And axis symmetric, we have we will only look at spherical shells. So there's like one page. And then bending of spherical shells. This one may not be for now, but we'll do it later, like once we are done with our presentation. And then this DMV is one of the what do you call, some updated shell theory. I mean, there is updated, so there is you can formulate that way you want, right? It all depends on how far we are from the Euler-Bernoulli assumption, or what we call as the Kirchhoff's hypothesis. Then we have buckling of plate sensors. So for today work, right? So we have to understand this one. So let's just go to in which page we'll have this strain energy, right? So that is our goal.
Okay.
Let's just see so that we can understand, okay, how we have to formulate. We are not looking at plates. We are looking at membrane state also now. Bending of spherical cells. No. Nonlinear buckling of plate cells. I just want to know which relevant section we have to look. So say we start with here, where will be the energy functional? Since our goal is to know the is there, huh? Did you find somewhere? Effective force, this one, right? Should we just see? Okay, page
91. Yeah.
Yeah, let's see here. Yeah.
Go to 91.
The thing is, yeah, okay.
91 by 2. 50,
92.
probably.
Yeah. Like once we are done with this presentation, we are going to read this book like anything. This book is, I think, the best. It's like at one place you have the entire shell theory. We need not to jump from here and there, right?
But
We should just pick.
but I honestly want to enter this shell theory through FEM, dude. But anyways, yeah.
The thing is, shell theory by itself, right? It's much more mathematical.
I know.
That's how I would like to call it.
Agree,
Then
I agree.
FEM, yeah, FEM is like how do we handle all those what do you call local manifolds, as we call, right? So it's all about how do we
So
handle those.
I am feeling like, because if you know how computation works, because it is already implemented in FEM. Of course, we'll go the way you're saying only. But
Okay, I understood what you. I mean, you meant to say that through that Phoenix sells that one, right? That package.
If we enter through that, no, we will have
Okay,
like,
yeah, I understand. I think that is.
ये shell काम कैसा करता है first.
Yeah, that's true. That's true.
Okay.
I think
Then
that is
while reading
that is.
also, no, like I will get, okay, यहाँ पे this is why he's writing that. That's basically how my mind worked better. But
Yeah, no issue, no issue. So we'll adopt that. I think that is also much better one. Yeah, since our mind is more tuned towards computing, right? Computing side.
Yeah, for me,
So I think it.
not for you. For me, it is.
No, even for me, it's the same. It's like I always look at things algorithmically. Like if I understand things algorithm, then it makes more sense.
Because
Otherwise, it becomes rote memory.
Yeah, because I'm looking at this SPH for shell, and he using some Mendelin Ulhad theory. And if I just look at the way he wrote, no, I will understand. Okay, here he's computing this gradient. Why is he computing? Okay, here he's computing stress. This is how he's changing the coordinate system. He's converting. It's very easy
I
to
see. Yes.
keep track
Right.
of. That's what I felt.
That's true.
But yeah,
That's
let's
true.
do it.
That's true. Yeah.
But I hope to. I hope to.
No, actually, we will actually learn about all that. All that MITC, right, approach.
Okay. Yeah.
Mixed
MIDC
interpolation of
and
tensorial.
PICR something. Yeah.
Yeah. So we'll actually go through all of that. I think that is much nicer way because we need
But
to understand those methodology.
this is also good because the way we read the Rees paper now, I'm
Huh.
reading this. He just repeated whatever Rees discussed.
I see.
Theoretical models, mein. I don't know if he really cited Rees paper 18 and 19. Let me see what he has in 18 and 19. Oh my God. This Ufulian paper is 1948 paper. It's before Mendelin paper. Okay.
Mainlands, they are more useful from industry.
Krishna, we have this plate theory in our aerospace engineering BTech curriculum now in fourth year or fourth year.
Yeah, but no one teaches, right? That's the issue.
I'm just wondering because वो तो easy होना चाहिए ना because वो BTech level का है.
No, but they will teach linear plate theory, right? Actually, in aerospace, we deal more with shells than plates, if you look carefully.
Okay, fine.
We hardly deal with, I mean, idealized plate models are only those tails. And wings also cannot be called as plate, right? I mean, you see, it has so much of curvature.
Okay.
So yeah, it's like yeah, but you know how they work, right? It's like their aim is not to convey knowledge, the curriculum.
I know, I agree, I totally agree. अरे मैं तो
Yeah,
मुझे I all remember is यहाँ से CSTS आ रहे तो वहाँ से आईना होना. That is all I remember. All the time it's like just that. You remember, no? You guys
yeah,
remember
yeah, that's true.
tau xy then वहाँ पे minus tau xy ऐसा होना चाहिए. I don't know
Ha,
what the fuck is happening with
that's true. That's true. Yeah.
this sucks. Yeah. Shell model, 2D plate shell model. This is a lovely paper, dude. Hey, can you please check this paper out once?
Which one?
I will tell you. Google this.
Huh.
SPH plate and shell.
SPH.
Plate and shell. Search. Space, of course. Plates and shells. Plate and shell, but anyways, yeah. Chilta.
This one, huh?
Not that one. Not that one. The second
This
one.
one. This one.
SPH with general. Wait.
Archive paper, huh?
Yes. I think it is not yet published. हो जाता है. Publish हुआ होगा, but पता नहीं कौन से journal में वो those guys might have pushed.
I see.
तो ठीक है. So go down. Go to theoretical models. So here he is discussing
62 pages, huh? It's
page
like
5.
heavy.
It's okay. Last छोड़ दो. Look, this theoretical models में 3D model, no? 3D model. Kinematics,
Hmm.
whatever we have seen in Reese, no? If you go scroll
Hmm.
down a little, you will see. Just slowly scroll. This is what we see, no? Yesterday.
Right.
Go down
The
a little.
same thing, yeah. Hmm.
So here, look. So first he defined the kinematics. मतलब ये ऐसा you should get the deformation gradient, you should get normal vectors like this. Then he's discussing
Hmm.
constant relation, the relation between stress and the
And strain.
kinematics, whatever F we
Hmm.
got. Okay, go to next section. So then he's doing stress correction क्या होता है, मतलब boundary condition how we will apply.
Hmm.
Okay, then you go for conservation equation, मतलब typical conservation equation like mass continuity and next section total nature.
Hmm.
So first 17 is conservation of mass and 18 is conservation of momentum. So you see that I will take those equations and substitute here, and bus. That's it. That's all you have for. 2.1 is plate model. Now the next section 2.2 is 3D shell model. Same thing he
Hmm.
repeated.
Hmm.
Then 2.3 is 2D plate shell model. So these are the equations we have. Then I know SPH, no. Then he just talking about SPH. Uske baad SPH, how we will describe this using SPH. It's tough. I can see it is tough. It has a lot of mathematics, but careful implementation can. But okay, this is not our prime goal or target. This is the way I want. Understand? FEM also,
Hmm.
we have exact same as we have some model, theoretical model. Uska FEM
Hmm.
ye hai boss. But it's all, I say likha hai, physics maybe. Of course, right? He took the shell model, then he did that variation formulation. That's what he did. If you look at the examples, the SPH to छोड़ ही दो, मतलब SPH is a simple conversion of those equations into SPH. Examples में took 2D oscillating plate strip, 3D square plate, dynamic response of 3D square plate,
Taken.
3D cantilevered plate. It's nice. So this is how it is organized. So I mean, time लगता है, but yeah, I'm happy. I'm happy we are doing this. Because next when I see this magnetism now, I will understand that okay, so because if we are able to implement this, at least me, because I know you can't do this because it needs a lot of SPH knowledge. No, it's not
Exactly.
it's not good. It's not good. Don't look at the repository. It's not so great actually. So it's good, but मुझे समझ में नहीं आया. So if I'm able to understand this, no, I'll see that take magnetism का force and add no. What difference would that make? He implemented 1948 ka theory only, not like he's doing something modern. So he's doing the classical. If I'm not wrong, I could be wrong here. So this is the SPH current art history. क्या बोलते उसको? Art of state of the art.
State of the art,
Sorry.
yeah.
Yeah, this is state of the art in SPH. See.
Yeah, that's what, man. It's like too many examples. He just does many examples. And he has
No,
just implemented that.
but I'm
Yeah.
asking, once we get this expertise in theory, shell theory, we can see if we can actually use SPH to do our micromagnetic stuff.
Hmm, 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 hmm.
I will be happy if we can do that. But their SPH is also there. FEM we can consider, SPH also we can consider. But anyways, I'm just showing you that as I had देखो ये भी एक अच्छा paper है. We can probably look at it at some point of time.
Right, right, right.
But let's
Like
read it.
this,
Let's read it.
yeah, these areas are still unexplored ones, right? I mean,
They are not. They are not.
very
You're right.
few touch are able to touch it. That's what I
I
say.
agree. I completely agree. अरे भाई ये
Mm.
पूरा theory, I think nobody can sit and do this one.
Yeah, it's not
Somehow
that.
somehow these guys are able to push.
Huh, huh, huh. So coming back here, actually, we will just want to know how they have done all that E
Yep.
alpha beta, right?
Yep.
Even in what you call in Phoenix, you can provide an equation in its variational form.
But you
So it,
have you observed one thing though?
huh, huh, huh.
I mean, you definitely might have observed, but I'm just making a point here. So in these
Hmm,
equations, the SPH
huh.
doesn't need this variational formulation kind of thing.
Yeah, the thing is, they have just taken the weak form. I mean, already tested, multiplied with what they call the test functions, and then integrated over the domain.
But
So that's
in
what they do.
SPH, you wait in SPH.
But in SPS, you may not require all that, right?
No, that's
Because
what I'm
we are,
saying.
yeah, we are
Exactly.
doing all those finite this one,
Exactly. So in
isn't it?
SPS, you
Yeah.
don't need to
Hmm.
multiply and get this new form.
Exactly. Yeah.
Okay. But
And
all the
once you
papers where
eliminate, yeah, once you eliminate the variations, right, then it becomes much more, at least mathematically less complex because taking variations with constraints, like
okay.
the issue especially happens with say quantities which tend to maintain their some what you call some feature, I mean some what you call properties. Say if you have a rotation matrix, right? You have a rotation matrix and you know very well that the rotation matrix is an orthogonal matrix, right?
Okay.
Yeah, so it has that R, if R is a rotational matrix, then R
R transpose I.
transpose,
Yeah.
yeah, is the same as R transpose R, right? Or is equal to R, is equal to I, isn't it?
I. Yeah. Yeah.
The issue is when we take variations, when we
Okay.
what we call incorporate variations or introduce variations to the rotation matrix, even after variations, it must still satisfy the orthogonality condition.
Okay.
So that makes very tough. So whenever you see sine theta cos cosine theta in expression, and you say, okay, let's take variation. No, the thing is, it's not straightforward. It's you have to ensure that even the perturbed quantity also has the same property. Say it's like R tilde transpose R tilde is equal to R transpose R tilde R tilde transpose is equal to I. It still has to maintain that. So we have constraints on even the perturbations.
Mm,
So you
I
know
see what you're saying.
how tough it becomes. So it's usually the rotation matrix which creates problems in when taking variational in its variational form. And even if say if you have say coordinate system which are local in nature, then it's again another headache. You have to take into account Christoffel symbols, deal with the rate of change of the vectors with respect to the curvilinear coordinates and the components in different curvilinear coordinates. So that all comes into play, and that makes it very complex. And that's the reason people just want to go towards this what do you call more sophisticated. I mean, mathematically, it's ideal. I mean, fundamentally, they appear to be more what you call sophisticated, but implement in on implementation sense or not implementation from a mathematical sense, then they tend to be little easier actually compared to if we had done the rigorous FEM approach.
So why? I mean, yeah, I understood the point you're trying to say.
Ha,
Why?
ha, ha.
What I am trying to not push exactly, but what I'm trying to say is if you are able to get this, I mean, not you, if somehow you, even SPH, if you look into SPH, no, like
हाँ
they
हाँ
need
हाँ
magnetism. Magnetism तो
हाँ
क्या है? एक additional force, no? That's it. If I'm
exactly
not
हाँ
wrong, right? You
हाँ
take the
that's true
force, you apply the force, and it's done. And it's
हाँ
very
हाँ हाँ
simple. To be honest, it's very simple. जहाँ तक मुझे पता है.
हाँ हाँ it's
Very
true
simple.
it's true
मतलब it is maybe FEM maybe easy होगा because when you know FEM that much, no, you will also feel give me the potential. I will add it, and it's easy. So it's either way.
हाँ हाँ
It's either way. And but let's do it. Let's get this thing on the track, back on track.
हाँ 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 हाँ
So you are at potential energy ka.
yeah
How
yeah
to?
so it's like we just want to understand where this e alpha beta comes, right? Here you see, right? Okay, here we have see W is equal to, so we want to understand why this alpha and beta comes into picture, like you see, right? One alpha is numerator, one is
Yeah.
superscript and subscript. So that is what we have to decode. Once we decode that, then we'll now just directly start formulating it now. And now
Amazing.
it's,
That's
yeah,
amazing.
because we'll just pick up from there, start putting our expressions and then looking at. It's like then we'll have a complete expression of, even if it uses Christoffel symbols, but we can still, Christoffel symbols can also be derived. Yeah.
Okay.
And from the very outset, we will do axisymmetric. So it's like we will only few Christoffel symbols, maybe 2 or 3 will remain non-zero. Rest all will become 0. So that is our goal. Yeah. So it's like not to understand this E alpha beta. Okay, he has not told much
Nice.
about this. We need to understand where did he get this E alpha beta from.
Contd.
Mhm. It seems we may have to go to their chapter 1 itself, it looks like, because he has
Okay.
not presented it anywhere. Okay, no, plates is not necessary
So
right
this
now.
this
Yeah.
capital A is the strain, no?
Capital E is the strain, yes. E is the what you call in plane. I mean, not in. Yeah, it's like
Membrane.
yeah, membrane strain. Yeah. So it's like yeah, in plane only then. So we'll just take a look. What if we may discussed here tensor analysis. We also need to complete that video series, man, by this Eigen Chris.
What will you say this?
Yeah, once we are done with this, we'll go back to once we are done. I mean, with this presentation, then we'll go to Eigen Chris. Eigen Chris has a very nice lecture series on. It's a very short ones, but nice lecture series on tensor calculus.
You shared with me, no? It has
Yeah,
Christopher symbols and stuff like that.
right, yes, yes.
Yeah. But I want to look at this MIT car.
Yeah, the thing is,
This thing.
MIT is a full-fledged lecture series. This is more of a to the
Okay.
point lecture series. Yeah,
That's
to the
good. That's
point.
good then.
Yeah.
That's good. Much better. Yeah.
Yeah, it's like once we know to the point, right? Then we can, then we would like to
That's what we
dig
need.
deeper.
Yeah.
Yes. So zebra. So here he has even. So how does he do? This is like just okay. Zebra of tensors, right? With all this, then we understand how poorly we are trained as an engineer.
Dude, you can't do anything, dude, with engineering knowledge.
Exactly, man. That's the issue.
Unfortunate. पता नहीं मतलब तुम कुछ भी नहीं कर सकते हो बीटेक किया तो मतलब कुछ
हाँ
समझ में नहीं आता है कुछ कुछ एंजॉय भी नहीं कर सकते इट्स लाइक एटलीस्ट आई नो मच बेटर नॉलेज इन मूवीज लाइक आई कैन एंजॉय लाइक यू नो relate that this stuff with engineering is
exactly. That's what, man. Yeah. See, it's like these things should have been taught in. I mean, I mean, if you give very high what do you call entry value to engineering, right, then not every people will want to take up engineering. That's
True.
also necessary. Yeah. See, I mean, we should have learned all this in undergrad
Now
itself.
engineering has become a degree, dude. Right?
Yeah, that's what. Yeah.
It's like a degree. Just degree. You do other jobs. Go bank job karo. कुछ और
हाँ हाँ
करो.
हाँ.
This engineering is no more engineering.
No, no, no. Mostly bank jobs only. Yeah.
Yeah, bank jobs karo. Ki some other job. Go business karo. MBA. It's like became a degree.
हाँ हाँ
So
हाँ हाँ.
we expect that.
So we have learned that like this is the covariant metric, and this is the contravariant.
Mm.
So, and with covariant and contravariant is we should not really try to. I mean, at first it's also that we must memorize it.
Okay.
Then gradually start making sense, because otherwise we'll just be searching for the meaning. It looks like my voice is echoing.
Is it? No, not for me.
Actually, it echoes this side. Okay, is it? Am I unmuted somewhere?
I can hear you.
Now,
I can hear you.
I, it's still well, it's still
It's not echoing for me though.
for me it's echoing. Yeah.
So it's not my fault, no?
No, I
Is
don't
it,
think
is
because
it, is it not because of me, no?
no, it looks like because I'm yeah. Yeah.
Good,
So
still echoing.
so it's like still different.
मेरा echo problem तुझे आ गया. Anyway.
Okay, so we were at here, right? Metric, and then
हाँ है ना यहाँ पे fundamental mixed tensor.
where is that? Okay, okay. So we try to count. Associated tensor. Okay, I see. If AI is a contravariant tensor, is
Just back in like 10 seconds. Oh, God.
yeah, actually, I think still echoing, man.
Oh, is it? Not for me.
I'm hearing my own voice. Where is it?
Definitely not the volume.
Yeah,
Still, huh?
audible now?
You're audible.
Okay, still audible.
It's
Coming
frustrating.
back at me.
You can do something. Take your mobile, join through mobile.
I see.
Okay, add करो mobile को भी to the existing call.
Yeah. Okay, maybe I'll off from here.
You mute and volume कम करो यहाँ पे पूरा. And use your phone for. इस लैपटॉप का you make volume 0. Volume 0. Yeah.
Am I audible now?
Yes. Is it echoing?
I'm audible.
You are audible.
It's still reflecting in there.
Oh.
Finding sensors, are two devices connected there, one muted and one on.
For me?
Yeah, I think because yeah.
No.
It's like yeah.
Not
Well, better
for
what
me.
I'll do is maybe
I don't know.
Let's change. Let's join in other things. Maybe Zoom or something else.
Okay.
Or personal Teams is better. Right? Let's not waste time on this.
Yeah, maybe I'll just stop recording, I believe, and then we'll talk. Yeah. Okay, so we'll meet.
It's okay. Yeah. Sorry, just a moment. I'll show it here. So he has some highlights, but यहाँ पे highlights नहीं आया PDF में. Look.
Let's see.
He says corrections to PD model. ये पिछले लोगों ने नहीं किया. And this correction is not done by him. He bought this correction from PD Dynamics paper. And he's adding it in
I see.
FSM. So you understand, it's not nothing new. So he takes this PD Dynamics paper corrections. He brings, he developed SPH. He couples these two. That's how he.
So he actually modifies some volume findings, right?
Yes.
Looks like.
Correct. Like near the free surface, like near the free surface. Just this near free surface, I think.
Yeah.
This is how simple it is, bro. To start with aerodynamics. So you also have a look and see if you can find anything. Say about C. This guy didn't give any values of C, which is very surprising. You know, I've seen all the full paper I've seen, but couldn't find. And even the live reviewers, they didn't say anything like boss C ka value kahin pe to nahi likha. He wrote C is microelastic modulus. It can be obtained from strain energy equivalence principle. But let us see if he has anything in the papers. Yeah, L यहाँ पे C value. Yeah, यहाँ पे नहीं है. Yeah, that's what. So C value is yet to be found. Which is I don't know. Like how would you compute C from strain energy equivalence principle? I don't know how you actually do that. So this is the first cut understanding of mine of this dynamics implementation. So once we are ready with this, the first paper we can write is open source software for dynamics in Python. For
exactly, and then have some good examples, right, as validation cases.
Yeah. So as you're saying, as part of your course. Okay. So I have downloaded one book as well, but I will not share it now as I can do it. But so as our software, first we'll write this. Then we also have SPH already implemented. So the way we write it is PySPH has good potential. He says, why are you implementing in PySPH? Because PySPH mein I have DEM, SPH, multi-resolution SPH. I have done FSI in PySPH. I have done elastic solid bolids, elastic plastic in SPH. So इतना है PySPH में. तो इसमें pair dynamics implement करना is good. That's what we will say, and then we will improve. If you just say that I have developed this new code, some chota code hai, and develop here, then so many people will do it. No, he will not accept it. If you follow me, what I'm trying to say, that's how we pitch. So once we are done with that, so in your course or in our course, if you're recording and everything, then we can start with this. Then we'll do FSI coupling. Then first paper. Then next paper will be that one.
Yeah. So FSI coupling, then yeah. So in that will require like in the same framework or a different code, like
same
within within the same software itself, right?
Develop हो गया. Then उसके बाद we will write Spice page coupled with Dynamic Spice page. So we will add, and there's one thing. उसके बाद we will add, because Spice page में there is also multi resolution.
Yeah, multi resolution MRE.
नहीं किया अभी तक Dynamics multi SPS है कोई नहीं किया.
हाँ.
Okay.
Yeah.
That will be easy now. That will be a first paper. That will be like इसको बहुत citation मिल सकते हैं. We have to grab this opportunity like soon.
Right.
So as soon as we do this, like ये एक बार Dynamics implementation हो गया, then that's it. So multi resolution will take from our existing, like वो हमको develop करने की जरूरी नहीं है. सीधा लेंगे और सीधा same FSA developer, same examples. We'll write some 4 examples, and we will do those 4 examples to just keep on developing. Okay. उसके बाद since I have done DEM, I can add DEM to Dynamics. So that way we'll just write 4 chapters. A nice book, and we'll.
Right.
But first step I want us to do is, so next week we'll write the code Sida. Okay.
Yeah.
Only. We will not do anything fancy. We'll study together. I think that's a good idea. Is that right?
That's true.
I think that's a good idea. But in the free time, we can, or when we are away, we can see that how we can resolve the issues we face while we're actually developing this code.
Yeah.
Okay, so that's what I want to show. Shop sharing.
Okay. Okay.
Oh, so 1 hour हो गया क्या?
I don't know. I don't think so.
नहीं 47 minutes. नहीं 47 minutes में बात कर रहे क्या? Half an hour.
Yeah.
Anyways.
The thing is, they have not mentioned how long the recording has been, right?
Yeah.
So just.
So have you done any Dynamics in this few days?
No. Actually, I was just. I mean, this 2 days, no. Because I thought this lecture would have been yesterday. And then I realized that I filled the form and I didn't recall the date myself.
So I just looked at the paper, like नया paper क्या देखा था, and it was interesting. So I was like, okay, let me see, and I was able to understand, like, okay.
Yeah, actually, there is this APS coming, right? APS, this American Physical Society's March meeting.
Every 6 months होगा ना या इसमें?
No, it happens every year.
Oh, it was 6 months before. That's what I remember. I'm happy they made 1 year now.
Yeah, so the thing is, yesterday I just thought that I just felt like writing something, some abstract. So it is in.
Amul, it's playing well. Yeah, you should watch. Yeah.
Yeah, so I thought of writing some abstract. I started yesterday only.
You should.
Yeah. So
that's important. That's most important thing. ये Dynamics slowly we can do. So we'll just meet like this. Whenever we meet, we'll do Dynamics. I think it's a good idea. We'll read together.
Right.
I think that will be enough. So we don't have to just. So if you need some motivation now, like day अच्छा start करना है तुझे या फिर वैसा कुछ है. Okay, we'll just meet for an hour. We'll do some reading and coding, and that will give some ideas for us as well. And Yes, we can just get into our work as also.
Right. So what I did is I thought that it looks like shell theory, right, for magnetoelastic systems has not yet been explored properly.
Okay.
So the thing is, my guide, the thing is, he won't allow for APS meeting.
Huh?
The thing is now he has presented our work, right, PhD work in a conference in Japan. That IUTM conference. So now he just wants that we should write journal paper. Now no conference regarding the work that we do. So we are in the process of writing, as I had told you, right? We are in the process of writing. So I mean, it's going on slowly, but it's going on. But by this month end, we should have the first draft. That's what sir has said that. So he's writing the first few sections. So like introduction, methodology, and he asked me to write the numerical part and answers results as well. So I had written theory as well. So I sent it to sir, like the LaTeX file. So he'd be working on that. So the thing is, and if I say that, sir, I want to start something new, then he will just say, okay, but let's finish this work first.
Yeah. No. You. I don't think you should tell anything about pair dynamics to your professor.
Yeah. So what I'm doing is I have been part-time had interest in shell theories and all, right? The split theories, shell theories. So the thing is, I think that if I put abstract somewhere, it will give a hard deadline that you need to work, but there is one target there. And if yeah, so it's closely aligned with my PhD work because here also we are dealing with magnetoelasticity of slender structures, right?
Yes.
So little bit time, even in the lab, like in lab also, most of the time you don't know what you are doing, you're just sitting. So if and I'm just reading papers, I used to read papers on shell theories. I even got some codes by some professors at ETH, some Pedro Reis. He gave the COMSOL file. So I thought, okay, maybe it's better that I also explore shell theories because being in slender structures, we should have knowledge of every area. Plate theories, very strong background in plate theories, shell theories. Ruds and ribbons. We are already doing as my right now as part of my work.
Okay.
So I just wrote one very short abstract, just some general idea, just throwing around. And I think that there is some what do you call huge rebate on people who are from India, right? Like from lower income countries, which also include India's as per the World Bank fact sheet. So India belongs to the lower income countries, or lower middle income, LMIC they call it.
Okay.
So they give a rebate of around 89%
Wow.
on the registration fee. So okay, I said okay. Obviously, I cannot get the money reimbursed. So 89% on $340. It brings down significantly.
Yes.
So around 90, just 10% of the original fees. Around $35. So I think that $35 I can pay out of my pocket as well.
Yeah. True that.
Without informing sir. Like I mean, once the work, if I'm able to do something, then I can show the results to share. Thinking about doing some journals, etc. As then I can put in my PhD work as well, right? As research work.
Correct.
Yeah. So I was just
So
thinking.
see, the one thing is,
Mhm.
if I'm definitely sure. Have you ever done something like this? Whatever I have presented, Avitak.
Never know.
Once you do that, no,
Um,
then I'm sure that you will start to think that मेरा जो shell theory है,
yes.
that stuff, how I can use peridynamics to handle. For example, I'm just searching for you.
Sure.
Shell, shell theory, peridynamics. So in non-linear, so it's like shell theory is like plates, no plate theory. Is that what it is?
Yeah. Shell theory is like shells are curved plates.
Jane Reddy, no?
Yeah. Of course. Yeah. Jane Reddy
Jane
is, I
Reddy
think, one of the.
published a paper in 2016.
Pioneers in this.
I'll just share it here. It's much better to do that.
Sure, sure. Please do share it.
Is it sharing? No, not yet. Share screen. It's not broadcast. The hell is that? Yeah, it's broadcasting now. Is it sharing?
Oh, no, please share. No, I'm just waiting for
Can
you
you
to
see?
share. Yeah. Not
Can you
yet,
see?
not yet. Not yet, not yet.
I think so. At least, yeah. It's sharing, no? Can you see?
Yeah, yeah. No, it's yeah.
See? Elastic shells. That's what you're looking, no? As part of your research. Yes, this
Yeah, yeah, yeah. 16 years.
You read in
62
Texas
pages.
AM, I think. Yeah, read in Texas AM. For Indian C.
Okay, yeah, Debashish Rise, yeah, this
ISC.
professor at ISC, yes.
Wait, he's from?
Civil
Which
engineering
department?
department, yes. Civil engineering.
Civil है कुछ नहीं है देखो